welcome to Learn Extra Live, and we're doing maths literacy, hey?
Absolutely.
Measurement, please tell us more about it.
Hi, grade 10s. Today we're doing measurements. We're continuing from last week.
Okay.
So we're going to do a little bit more kind of revision of perimeter to area, and then hopefully we'll get to volume.
Okay, awesome. So that sounds awesome, guys. I hope that you've called everyone, one and all, to join us today for measurements, hey?
Thanks.
Okay, you can walk over to your board while
Thank
I
you.
let you know about our Facebook page. So you guys already know that we're on Facebook. I mean, some of you have already joined us. So, of course, for those who don't, it's facebook.com/learnextra, and our Twitter handle is @learnextra. Guys, Mathslit is always a lot of fun. So make sure that you send us every question that you may have and every query. Tell me how your week has been. I mean, it is Thursday, so quite a few things have been happening at school today in terms of maths literacy. And let us know how your dad's school went. I'm looking forward to being with you guys today. And as I said, if your little brothers and sisters are also making a noise, tell them to sit down next to you, grab a piece of paper, and join us today, because we are going to be having a lot of fun. Over to you.
Absolutely. Thanks, Kat. Guys, we're going to do measurement, but before we start, let us just discuss our numbers. So I'm going to go back to Katlego and ask her. Right, so last week, we were on 14,720. Nice to know that it's growing so much.
Yes.
But give me the good news. What's this week's number?
This week we have reached our 15,000 and over, so we're on 15,129.
That is so great. We are so close to the
Fantastic.
next party, which I
Yes.
hope I'm actually here for.
Yes.
now. So 15,000, that's really great. But guys, still, lots of people out there that are not on with us on Facebook. So pass the message along. Tell them how great we are. Okay, let's go back with measurement. So as I said, last week we did perimeter and we touched on area. And today I want to do a little bit of surface area. Possibly we're going to get to volume, but I'm going to be doing measurement again next week, so we will definitely cover all 4 of those by the end of next week. So let's just do a quick recap. So if we're looking at a square, I'm quickly just going to give you the formula. So your square, remember that was the outline. We need to do it, and it's in 1 dimension. So our square is our outline, it's our length, and there are 4 lengths, so it is 4L. That's your perimeter. For the rectangle, we've got 2 lengths and 2 breadths. So what we do, it's our formula is perimeter is 2 times, and then we add the length and the breadth. Our triangle, we're going to just label these side 1, side 2, and side 3, and our perimeter is then clearly just adding all 3 sides. And then moving on to our circle. And remember, on our circle, let's just get a green pen. The green line going through the circle from one side through the center to the other side is our diameter. And the white line going from the center to the circumference or to the outline is the radius. So let's get a white line color for that, is our radius. And our formula, let's use orange, our perimeter is equal to 2 pi r, and remember I said to you last week we only need to use those 4 function calculators, so we're always going to use pi equals to 3,14. So in actual fact we can write our formula as 2 times by 3,14 times the radius, or we can use the diameter, so our perimeter is equal to the pi times the diameter. Or again, let's substitute 3,14 times the diameter. So those are your formulas. Now, guys, remember, they're going to give you the formulas. We do not need to remember these, possibly just for a square or a rectangle. But even then, most of the papers I've seen have actually got the formula in, because we're not testing whether you remember the formula, we're testing whether you can apply the formula. So let's move on to area quickly. Right, our square, and I think have I got the formulas here? There you go. My square is length times breadth. So if I make that my length and that my breadth, but remember in my square, my length is equal to my breadth, so I can actually say area is length squared, or length times length. My rectangle, let's give us a length here and a breadth there, and this formula, area equals length times breadth. my triangle, this is my base of my triangle, and that's my perpendicular height of my triangle. And the formula, love this board, the formulas just appear. Well, they seem to appear. This one's not seeming to appear. Okay, well, let me give this one to you then. So the area is equal to half the base times the perpendicular height. Okay, and I write my perpendicular like that. Oh, look at that. Formula's probably underneath there. And lastly, the circle. Area of the circle is, there it is. Area is pi times radius squared. And again, we're going to change that to 3,14 times the radius squared. Now, for area, there is no formula where we use the diameter. So if you get a question where you have the diameter, you're going to have to convert it into the radius. And remember, the way we do that is your diameter is twice the radius. So we divide the diameter by 2. Okay, I think that's enough of a recap from last week. Let's go through a question. That's the best way to actually realize if we understand the concepts. Right, so question 1 says, the committee at the local soccer grounds wants to investigate the possibility of creating a new design for their soccer fields. They want to use color-dyed grass in different areas of the field, as shown in the accompanying diagram. So let's go look at the diagram, and we'll come back to the table. Right, here is my diagram of my soccer field. So what they want to do is they want to make the outline of the field in yellow. Then they're going to have a green, they're going to have a green soccer field. Try to find that again. A green field where the goals are in blue and the center circle, now soccer's not that good. The center circle, I was going to give it a name, but it's
Rather
not
not.
sure. We'll call it the center circle, it probably is that, is in red. Okay, so it's going to have this brightly colored, and I think it'll look like quite a nice field, don't you
Yeah,
think?
I think
Okay,
so.
let's go back to our table. What does our table tell us? Oh, there you go, it's the center circle. Right, our penalty area is going to be blue. The length of the penalty area is 40 meters by 20 meters, and the cost per meter squared is 125 Rand. And there are also 2 penalty areas. Then we've got our center circle in red. It gives us the diameter of the center circle and the cost per meter squared. The rest of the field is going to be green. We've got our length and breadth and our cost. And then the border around the playing field is going to be yellow, and it tells us all our measurements. So along the side is 3 meters, and behind the post, 5 meters. And again, we've got a cost. Right, calculate the area in meters squared. And this is what is so important, to realize what units they want the answer in. So everything we do now has to be in meters. We're calculating the blue grass needed. So we're going to look at our drawing, and we're going to see that we need this blue grass there and that blue grass there. So there are 2 of them. So my area is length times breadth. But there are 2 parts, so I'm going to add my 2. Okay. So what is the length? And now what I like to do on my diagram, let me take this blue line away, is I like to add the length and the breadth to the diagram. So if I count that as my length and that as my breadth, it is easier for me to substitute in to the equation. So now I see that my length was 40 meters, my breadth was 20 meters, and I need 2 of them. Now 2 things have happened. When I've substituted on all the values, I've left out the meters. I find that they can be confusing, and you might find this too. So leave out the units in your calculations. Let's do this calculation, get an answer, and then we will add our units. So let's get our calculator out, and we see that it is 40 times 20 times, there were 2 of them, and it's 1600. So go back to that. It is 1600. Now I need a unit, meters squared. Go back, have I calculated the question correctly? It says calculate the area in meters of the blue grass. Got that. Let's move on to the next one. The green grass needed. So my green grass, let's go back to my diagram, is a little bit more confusing. So on my green grass, that is the entire field minus the 2 penalty areas, those are the blue ones we've just calculated, minus the center circle. So we're going to work out the entire area and minus these 3 shapes. And I've already calculated those 2 shapes, the area of them. So let's see. My length, let's do this in green. We've got green grass. My length is 120 meters. My breadth is going to be, breadth is 60 meters. Right, that's the breadth. So I'm going to calculate that first. So let's work out. So, and I'm actually going to write it out. Area of the big rectangle minus the area of the center circle and the 2 penalty boxes. And that's how I'm going to put it down, because it's logical and then anybody can follow. So the area of my big circle was length times breadth. A little bit more space, and that was 120 times by 60. Right, let's calculate that. 120 times 60. And we get an answer of 7,200. So 7,200. Now I still need to minus the area of the circle. So the area of my circle, remember, was pi, which is 3,14, times the radius squared. So it is 3,14 times, now what was the radius of the circle? So let's go back up to my diagram, and I see that on my circle I have a diameter of 20. So if my diameter is 20, my diameter is 20 meters. For my radius, I need to divide by 2. So that's going to give me my radius. So 20 divided by 2 is my radius is 10 meters. Now, if you get into the habit, whenever you've got a circle, of writing out what the radius is, it'll also make it a whole lot easier for you to do the calculations. So add that to your diagram. And here we've got, let's go back to my green, radius, which was 10 meters squared, 10 squared. And I'm going to add, well, this I've got to minus those 2. The 2 penalty goals, which I've already calculated as 1,600 meters. Well, let's do this calculation on the calculator. Right, so where's my calculator? So I'm going to use pi, 3,14, times by 10 squared. Now, if you're not using a scientific calculator, if you're just using a plain 4-function calculator, then what are we going to do is we're going to say, let's delete the square, we're going to say 10 times 10. That's what the squared means. Let's get an answer. It's 314. So we're going to double check that that's the same thing. 314 meters squared. And I need to add the 1,600 that I've already calculated. So we're going to add that first. Now, I don't think I need a calculator for that. So it's 1914. We're going to minus it from our 7,200. We'll need a calculator for that. So 7,200 minus 1914, and we get 5,286. So 5,286, and remember, now we need our units. This is meters squared. So that is our area of the green grass needed. Let's see what the next part of the question asks us. Right, we've got our picture again. Calculate the cost of the red grass needed. Now they want the cost. Earlier we were just calculating the area. Now to work out the cost, we're going to have to work out the area, which in fact we've just done, but we'll do it again, and then multiply it by the cost per meter. So let's find a little bit more space. In fact, we have worked this out before. So our area was 3,14 times 10 squared, and we got our answer of 314 meters squared. Now I need to times it by the price. So we find out center circle, that's the red one. Our price is 120 Rand per meter squared. So all we're going to do is take our answer here and times it by 120 Rand. So we need a calculator out. Right, so it was 314 times by 120, and we get an answer of 37,680 Rand. And remember, there's a reference to that. It is rands. So we got our cost. It seems like quite a lot of money to paint
There's a lot of
paint
money.
just the center circle.
Yeah.
Right. Okay. Let's see what our next part of our question is. Right. Thick, solid lines on the diagram indicate the markings needed in the game. These are drawn using special paint for sports field. What length, and they want it in meters, of white paint is needed to mark the laying field, excluding that around the yellow border, and give your answer to the nearest meter. So, and then they give us the formula for the circumference. What do we need? We want excluding this line here, that we're not looking at. We are looking at all the white lines here, and remember, not the arrows. So, we're going to need 3 60s minus this little piece in the middle. Okay? We're going to need 2 120s. Then we're going to need our circle here, and we need 4 20s and 2 40s. So we're going to add all those up to actually get our answer. So the easiest way to do this is to actually draw them. So what are we going to do? Right, I need the lengths. So it's 120 meters, and I need 2 of those. Okay, let's times by 2. Then I'm going to add, I said I needed 3 60s. But from that I need to minus my diameter. So let me go back to my drawing to show you what I've done. I've said I need 2 120s. Those are those lines. Then I need, let's get a different color. Then I need 3 60s, but I do not need the circle to be painted. So I need to minus this in the middle, and that is 20 meters. So I need a 60, 60, another 60, but minus 20, and then I'm going to do these other ones. So how many 40s have I got? I've got 2 40s, and I've got 4 20s. Let's add that to our calculation. I needed 2 times 40 plus 4 times 20 plus my circle. And my circle was 3,14 times the diameter, or 2 radii, which is the diameter, so we've got 20. Right, and with that I can now do all these calculations, and I should get my answer. So have I got everything? All I've painted, I haven't painted the last, which is my circle. So let's do these calculations quickly, and then I think it might be time for a break. 120 times 2 is 240, plus 3 times 60 is 180, and I need to minus my 20. I'm going to put that in brackets, plus 2 40s are 80, 4 20s are 80, and the last one that I do need my calculator for is this 314 times 20. 3,14 times 20 is 62,8. Right, and now I can add these all. So this becomes 160. So let's add this all. Right, my calculator. I've already got that number in, so let's now just add our 240 plus our 160 plus 80 plus 80. And that should give me the entire thing, 622,8. So 622,8 meters. Now, what did the question ask us? The question actually said, calculate to the nearest meter. So I'm going to round this up to 623 because I can't have a part not painted. So 623 meters is our answer. We've got the entire thing painted. I think we should take a little bit of a break. Give them a bit of a stretch or
after the soccer field,
after the soccer field.
colourful soccer field. Guys, let's take a really quick break. This break is for you to maybe get some things clarified for you in this question, and perhaps if you have any other questions, start sending them through. See you after the break. Welcome back, guys. I hope you grade 10s are now ready and steady for this session. As you know, we are doing maths literacy and we're doing measurements today. So it is really cool. We're painting a soccer field, many different colors, and we're going to go on to even more questions. So if you perhaps have questions on what we have just done, maybe it's better that you ask them now before we move on and it's too far. So just make sure that you are clear and you know what is up. Hey, Hayley?
Absolutely, guys. Welcome back. So we had just worked out how much paint how many meters we needed to paint the field. Now we're going to get a question which says, right, thick solid lines on the diagrams indicated where they need to be painted. If we use 250 mils of paint for every meter of marking, how much paint will be needed? And give your answer in liters. So all of a sudden we've been doing measurements and we've been doing area, and all of a sudden they throw in a ratio question. Now I don't want this to throw you because, guys, they're going to be asking you different skills in different sections. So you think, okay, well, I know how to do measurement, but I can't remember how to do ratio. You need to be able to do everything because they come up all over the place. So what does this tell us? Right, we know that we have 250 mils for every 1 meter. We also have just calculated that we need 623 meters, and we want to know how much paint do we need. Now they want our answer in liters, so we can either convert into liters now or we can convert into liters later, but at some point we're going to need to convert. So I'm going to leave it as is, and I'm going to say, well, okay, how do I do this ratio? What do I do from 1 to get 623? Well, clearly I times it by 623. And I need to do the exact same thing here. So times by 623. So my sum is going to be 623 times by 250. And I'm going to get my answer. So let's get our calculator out. Right, so 623 times by 250. And I get an answer of 155,750. But I need my answer in liters. So let's convert to liters. We're going to divide by 1,000. 1,000, there are 1,000 milliliters in a liter. And my answer is 155,75. So 155, I'm going to just write this in. That was milliliters. To show you, then we divided by 1,000 and we got our answer of 155,75 liters. Now the question said, how many liters do we need? Now I'm not going to go to the shop and say to them, I need 3/4 of a liter. So I need to round this off to a whole number, and I'm going to have to round up to 156 liters. So we always round up in this situation because we don't want any part of our field not painted. So we rather have extra paint. Right, let's move on to the next question. Right, we've got the floor plan of Greg's kitchen below, and we need to answer some questions. So this looks very similar to a diagram that I gave you last week. He wants to paint the kitchen blue. So if the height of the kitchen is 2,25 meters, calculate the total wall surface area of the kitchen. Now we're looking at, this is the floor plan of his kitchen. So each one of these lines is in fact a wall with a height of 2.25 meters. So I can work out the area of every single wall individually. So basically say that this will be 5 meters times 2.25. 2.25. And then this will be 7.5 times 2.25. Or the easier way of doing it is actually work out the perimeter of the entire kitchen, and then we times it by the height of the kitchen. So kind of if I had to lay it out flat. So I'm looking at the south wall and then the east wall and then etc., etc. So it's going to be 5 plus 7.5. And I think we did this last week. So let's quickly revise that. First of all, I need that area there. So we've got 7.5 here, minus the 6 on that side. So this was 1.5 meters. And I think I've got all the other measurements. Now I need this measurement here. So that was 5, and this is 6.5 plus 2 meters. That's 8.5. So this here is 3.5. So now we take our calculator out, and I'm going to work out the entire perimeter. So I'm starting, and I'm going to start over here with this 4. Oops. I'm going to color out. I'm going to start here, and I'm going to walk around the around the shape. Right, let's get our calculator again. Right, so we're going to start with 4 plus 3.5 plus 1.5 plus 5 plus, now let's move our calculator a little bit to do this side, 7.5 plus 2 plus another 2. Okay, that leaves me at the bottom. Right, we've got that 2 in. So now we've got 6.5, 6.5, and that brings me back to my x. So what is that? 32 meters. So let's write that in. Our perimeter was 32 meters. And you can tell me that you added them all up. Right. And I'm going to now work out the area of the walls. So that's going to be my length times my breadth. Well, my length in this case is my perimeter, so that's my 32, times the height of my wall of 2.25 meters. Get our calculator out. So we can times that by 2.25, and we get an answer of 72. And now my answer is 72 meters squared. That is what he needs to paint all the walls. The kitchen has one door measuring, and there's our measurements for our door, and 2 windows measuring those. Calculate the wall area that has to be painted. Now, of course, if we're painting the walls, we don't want to paint the windows or the doors. So we have already worked out the area of the walls. So we know we've got the area of the walls. And we need to minus the door and the 2 windows. So what we can do is we can do these calculations. That we know is 72 meters squared. Now, the area of my door is length times breadth, so that's 1.5 times 2.1. And my 2 windows, which are 2.2 times by 1.2. And we can do that all on our calculator. So let's get that out. So it was 1.5 times 2.1 plus 2 times, right, 2.2. Let's get the calculator. Let's move the calculator rather. 2 times 2.2 times 1.2. Now, guys, please remember, if you are using just the normal calculator, that you need to do this in stages. And you need to press equals between every calculation so that you are actually following the BODMAS rules. So that answer is 8.43. So let's write that in. 8.43. And now we can do 72 minus that. Oops. Right. So I've got 72 minus 8.43, and my answer of what needs to be painted is 63.57. And what my units? Meters squared. So we've calculated the area of the wall that needs to be painted. That's perfect. Let's move on. Right, now we've got the next question. Mrs. Sander decides to hire Bathwiz to retile her bathroom floor. The scale drawing, now that is an important word. Scale drawing means that it's drawn to scale. So it's just, and we did this, I think, with map work. Well, I hope that we've done it this year. But we've taken our picture and it is in exact proportion of our real bathroom. So this is illustrated alongside. What does she have in her bathroom? She's got a door, she's got a bath, and she's got a basin. The length of one small square is 20 centimeters, so that's a really important fact. The fitted wash basin and the fitted bath are illustrated in the photographs below. The area under the wash basin and the area under the bath will not be tiled. So there we've got our bath, our basin and our bath, and in our little picture here, they are not going to be tiled. All right, let's move to the question. What is the area in meters squared of the bathroom floor does the bath cover? So we want to know how much the bath covers. So let's go back to my drawing. Right, and I know each one of these small squares is 20 centimeters. So I'm looking for the length of the bath and the breadth of the bath. So I can see that there are 3 tiles that cover the bath. 1, 2, 3. I've added them up, so it's 3 times 20. Okay, so we've got that is 60 centimeters. And then working across the bath, how many squares have I got? Well, I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 squares across. So my length is going to be 9 times 20. That's 180 centimeters. Now I'm going to take that fact into my area. So they wanted our area in meters squared. So my area is length times breadth. My length of my bath was 180 centimeters. And my breadth was 60 centimeters. But remember I said to you last week, always convert your measurements first. So I want you to change these into meters first. So I'm going to write this. I really think that's really important to convert first. Because what's going to end up happening if I don't convert first is I'm going to have centimeters squared, and then it gets a little bit tricky converting from centimeters squared into meters squared. So let's make it simpler, and let's divide those both by 100 to get them into meters. So we've got 1,8 meters times by 0,6 meters. And my answer to that, I need my calculator, 1,8 times by 0,6, get an answer of 1,08. 1,08 meters squared. Have I answered the question? I have done so. Next part of the question says, calculate the area in meters squared of the bathroom floor that needs to be tiled. So now we're looking at what needs to be tiled. So we're going to do the whole floor minus the bath, which we've just calculated, and the basin. So let's put in our bath measurements because we know that 1,08. Whoops. Let's work out our floor. So I need to go back to my diagram, so you're going to have to bear with me while I find it. There you go. Right, how many tiles are in the bathroom in its entirety? So let's get a different color out. And we counted 9 across there, so clearly there are 10 in total. So we've got 10 times 20. That's 200 centimeters in length. And my breadth, I've got now 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 20 there. So that's 180. I'm going to change that straight away. So we've got a 2 meter by 1.8 meters. While we've got the picture up, let's see how many are in our basin. There's 1, 2, 3 across and 3 down. So my basin was 60 centimeters by 60 centimeters. Definitely looks like this. Right, 60 by 60. So let's go back to our calculation. Right, what did I say my floor was? My floor was 2 meters by 1.8 meters. We're minusing that. And the basin was 60 centimeters, or 0.6 times 0.6. So let's do these calculations one at a time. So I've got 2 times by 1.8 gives me 3.6 meters squared. Minus, I'm going to this 1.08 plus my basin, which was 0.6 times 0.6. I get 0.36 meters squared. And I'm going to add those up and minus it from the 3.6. So by 0.36, let's add my bath, get an answer. That was 1.44. And then 3.6 minus that gave me 2.16. So 2.16 meters squared is what needs to be tiled. So I hope that you're following that whole logic. So whenever you get a question like this, kind of make little drawings for yourself to help yourself along with what you need to do. Or little, you can write it out like I did. Let's see what the next part of the question is. Determine how many full boxes of tiles Mrs. Sandler must buy to tile her bathroom. The following information will help you with the question. Right, so we've got one box of tiles covers 1.5 meters squared. She's advised to buy 10% more tiles than she needs in order to allow for cutting of the tiles and for breakages. So let's take our calculation we've just done. So we had our area of our floor was, we said 2.16 meters squared. That's what she needs to tile. It was 2.16, am I right? 2.16, just double checking. Right, we need an extra 10%. So I'm actually going to increase this by 10% by multiplying by 110%. Right, so let's get our calculator out. We've already got that number in there, so I can times that by 110%. Get an answer. We need 2.376. I'm going to round that off to 2.38 meters squared. Right, we know one box covers 1.5 meters. So what I need to do now is I need to say, well, one box covers 1.5 meters. How many 1.5 meters have I got in this 2.38? So I'm going to take my 2.38, divide it by 1.5 to see how many boxes I need. So I've got my answer. Right, let's clear that and get 2.38 divided by 1.5, and we see that we need 1.58 boxes. I can't have 0.58 boxes, so I need 2 boxes is what she needs. And you could have done this with kind of logic. You could have said, well, 1.5 boxes. If I get 2 boxes, that's going to cover 3 meters squared, so I need 2 boxes. So have we answered our question? It says determine how many full boxes of tiles she must buy to tile her bathroom. She needs 2 full boxes. And I think that takes us to the end of this question, so I think it might be time to take a bit of a break.
Yes, let's take a bit of a break, Haley.
Absolutely.
And I know that you want some questions now. So guys, send in your questions, please. Send them through fast as well. Even if you don't have questions, perhaps send something to show us that you're understanding. Let's put it like that. See you after the break. Welcome back, grade 10s. Great interaction on the page. As you know, a few of us have joined us. Some of you are probably still busy at school because it is a Thursday. But if you are home, then you better just stick to this channel and join us on our Facebook page, which is facebook.com/learnextra. So make sure that for these last few minutes, you are with us 100%. Over to you, Haley.
Thanks, Katlego. Right, guys, welcome back. So now we're looking at a new question. We're on question 4. We've done quite well today. We got Mr. and Mrs. Gelman would like to make a donation to help upgrade the local sports field. The sketch below shows a plan of the field. The measurements on the diagram, not drawn to scale, are in meters. So those are important facts. And then they give it to you again, actually, in the text. The sports field is made up of a rectangular grass soccer field, and those are the measurements there, 2 semicircular seating area with a radius of that, and 2 rectangular paved areas with 5 meters. The paved areas separate the seating area from the soccer field. So what have we got? We've got our soccer field, they've given us our dimensions, and they give it to us again in the sketch. We've got a paved area, which is 5 meters wide, and then we've got a semicircle, 2 semicircle seating areas. So basically people are just sitting kind of behind the posts, behind the goals. What do we call it? Soccer. Goals. Goal posts. Okay, so let's see what the questions brings us. The Gelmans donate 3,000 Rand to buy fertilizer for the soccer field. Calculate the area of the soccer field. Right, well, our area is our length times my breadth. And my breadth here is 95. So I'm just going to add that. I'm not sure if you can see it that well in this color. So that is 95 meters. I'm just moving that up to here. So my formula, my area is length times breadth. So my length was 80 meters times by 95. And in fact, I'm leaving these meters out. 80 times 95. And I need a calculator for that. So 80 times 95 and 7,600. So 7,600, and now I need my units. So what do we got? Meters squared. The next question says, calculate how many bags of fertilizer can be bought with this donation if 1 bag of fertilizer costs 49 Rand. So we know that 1 bag costs 49 Rand. We want to know how many bags we can get for their donation of 3,000 Rand. So what we need to do here is we need to see, well, what did we do from here to get to there? We actually times by the reverse, so we times by 3,000 and divided by 49, and we're going to do the same thing here. So we're going to say 3,000 Rand divided by 49 Rand is going to get me how many bags we can get. So on the calculator, 3,000 divided by 49, and we get an answer of 61,22. Now in this case, let's write that in, 61,22 bags. Again, I need to round off because I cannot have a 0.22 of a bag. And the question is, must I round up or round down? Now, in this case, I can only round down because I don't have enough money to buy 62 bags. So I, in actual fact, can only buy 61 bags of fertilizer. So let's move to the next part of the question. Right. They would also like to donate money to fence the perimeter of the sports field. Determine the length from A to D. Now let's find A to D. So from A all the way to D. So we need to determine this length. A, we said, was 5 meters. The length of our soccer field, so BC, is 80 meters. And this paved area is 5 meters. So 5 plus 80 plus 5 is clearly just, let's get this in, 90 meters. Right, next question. My M doesn't look so good. Right, now we want to determine the length of the curved part, this DEF. So let's find DEF. We want to calculate that area there. So remember they told us that was a semicircle. They also told us the radius. So I want to find my radius again. My radius was 47,5. 47,5 meters. So they've given us our radius. In fact, they didn't even need to give us the radius because we have the diameter of 95. So my radius is clearly half of the diameter. And we can see that that's perfect. So we want the curved area, and we're going to use our formula of 2 times by 3,14 times my radius of 47,5. I'm going to get an answer, but now remember this is for the entire circle. So what I actually need to do is I need to divide that by 2. So if I divide that by 2 straight away, I can see that my 2's cancel. So I can in actual fact just say 3,14 times my radius. But if this confuses you, then what I want you to do is I want you to take your calculators and let's type in those numbers exactly, the formula exactly like it is in the text. So that was the 2 times the 3,14 times by my radius. Get an answer, and then I'm going to divide that by 2 because I only want the outside. I only want the semicircle. So it's 149,15. Right, that's that part. Now we want to know determine the total perimeter. So my total perimeter is those 2 measurements that we've calculated. That was 90, plus my 2 semicircles, which was 140, what was it, 149? I had it on this calculator. 149,15. Right, so let's get our calculator out. And on my calculator, I've already got my semicircle. So I'm going to times it by 2 because I've got 2 of those semicircles. And I'm going to add my 90 from the one side plus my 90 from the other side. And I'm going to get a total answer of 478,3. (478,3), and don't forget your units. So our units are meters. Right, let's see what the next part of our question says. Next part of our question says, if the total perimeter of the sports field is 478,3. I love these kind of questions where they actually give the answer in the next part of the question. That's just what we've calculated. And we need 4 gates, each of 2 meters wide, are put into the fence. Calculate how much fencing will be needed. Well, we need our fence minus our 4 gates. And so we know all these facts. Our fence was 478,3, and we're minusing 4 gates, each of 2 meters. So we're actually only minusing 8 meters. So we can say that minus 8, and I think we don't need a calculator for that, to say it's 470,3 meters. How are we doing for time there?
I think we have a few more minutes.
Have we got a
left.
few more minutes?
Yes.
Do you think I've got enough time to start the next question? So I think
Is it-
maybe
it's not
we're
long,
going
is
to
it?
leave. You know what? It is quite a long question, and it goes into volumes. I think I'm going to leave the question, but I know I've got a bit of time. So what I'm going to do, because I feel like I've been talking at like 1,000,000 miles an hour, so I'm going to just talk to you for a few moments. In fact, I can put that down. So what we've done today is we've done area and we've done perimeter. We didn't get to volume. We did a little bit of surface area, only in that of the painting of a room. So I think we'll do a little bit more surface area next time. So, but what I want to remind you guys is when you're doing these sections, break them down. Take your drawing, add labels to the drawing, kind of show where your lengths are, your breadths, your sides, or whatever it is. Do little drawings, because that actually helps you to answer the questions. Because I know, Kat, my kids, when I teach them this in class, they go,
Yes.
I can't do geometry. And I said, but it's not geometry. This is everyday stuff. This is stuff that we can relate to.
Of course it is,
And I
yeah.
said to them, just take it down. You've got the formulas. You kind of need to substitute into the formulas, but if you look at your diagrams, you actually can pick out quite a lot of information from the
Yeah,
diagrams
of course.
to help you. So don't be scared by the section, because I find that Maths Lit kids often are scared by the section, and it's just
Yeah,
very
and everything
frustrating.
is basically in the question as well. Hey.
Absolutely. So they need to take a deep breath. But I think on that note, I'm going to say goodbye, hand you over to Kat, and we'll see you again soon.
Okay, thank you, Haley. And I hope maths literacy teachers don't try trick you. In fact, no, I don't hope. I know they don't try trick you. So everything will be in the questions. Everything is set out properly. You just need to read. I mean, some people don't really read. Hey,
That's a
Haley, they just
problem.
miss out like numbers and they miss out specific things that they have to say, especially on the calculator. They miss out the numbers that they have to put into it. So just make sure for yourself you keep focused and you know that the numbers that you see you've actually put into the calculator. And it doesn't hurt to do a question twice, because you do find that you do make just little mistakes because you're human. On that note, guys, thank you for a very fantastic show. You guys were absolutely awesome. See you for more maths literacy on Thursday. Bye, grade 10s.